Have you ever wondered how energy and matter flow through the ecosystem, from when it enters as sun energy to when things decompose and return to the soil? Hi everyone, welcome to a short lesson on energy in the biosphere. This is outcome A1.1. So the Earth can be considered a closed system, which means nothing leaves our atmosphere, our biosphere, our hydrological system, or enters it. I mean, there are very few exceptions to this, such as if an asteroid entered Earth or a spaceship leaves Earth. But in general, we consider the Earth to be a closed system. So whatever we have here is what we have, and nothing new is coming. So the Earth does not receive new matter like the energy system does with energy from the sun. And so therefore we're bound by the first and second laws of thermodynamics. So energy is not created or destroyed. It is merely changed from one form to another. This is the first law of thermodynamics. So if you think back to your Science 10 class and your physics lessons, you talk about how we have kinetic energy and potential energy. We can have chemical energy. We can have thermal energy. So all these different forms of energy are here on Earth, and they just get transformed from one form to another. And the other one is no conversion is 100% efficient. And again, if we think back to our Science 10 classes, the loss of energy most often is heat. And when you think about plants and animals and moving around, we spend a lot of our time and a lot of the energy and all those calories that we consume just keeping ourselves warm. And then also moving around. So most of the energy that we consume is lost. So we lose energy as it's passed along a food chain. So as a general rule, only 10% of the energy that's present at one level is passed on. So if we do just a quick, if plants have 100 joules of energy in them and a deer eats them, that deer would have 10 joules of energy left over in its muscle mass from the plants that it had eaten for a wolf to consume. And then if something like a hawk was consuming that wolf, there would only be 1 joule of energy left in that system, in that muscle mass, to pass on to that next level. So again, our rule of thumb is that 10% of the energy is passed on to the next level. So due to the fact that we have only 10% of the energy that's passed on to the next level, this affects the number of trophic levels that we can have in an ecosystem. And again, each trophic level represents a level through which energy and matter are transferred. So each step in a food chain. So the first trophic level is our producers. The second trophic level would be our primary consumers or herbivores. The third trophic level would be our consumers or carnivores. So the energy will go through each one of those levels. So a food chain is a model showing a linear pathway through which energy moves in an ecosystem. So we would go sun, grass, grasshopper, gopher, hawk. A food web shows connections between many different food chains. So we would have sun, grass, and then from that grass, we might go grasshopper, gopher, deer, cow, and then move on to different consumers that would consume those organisms. So here we have one that goes grass, mouse, snake, hawk. So we'd have grass would be our first trophic level, mouse would be our second trophic level, snake would be third, and hawk would be fourth trophic level. So we have a producer, a herbivore, and then followed by 2 carnivores. As opposed to the food web that you can see on the other side, which has 3 different producers. It has grass, a cactus, and leaves. Then it has the different primary consumers are our second trophic level, the herbivores that consume those. So we have a mouse, a beetle, a hummingbird, a butterfly, and another type of songbird, which then could be consumed by lizards and scorpions, possibly snakes, roadrunners, and then our final consumer is the hawk. That would be our tertiary consumer if we follow those food webs up. So what we see in a food web is many more connections between the different organisms in an ecosystem as opposed to the linear one. We can see that the effect that there would be if, for example, we took out the prairie grasses. There are 4 different organisms that eat those prairie grasses, and some of them don't eat the leaves or the cactus. So that's their only source of nutrition. Versus if we took out, say, just the cactus, we might see less of an impact in that ecosystem based on this diagram only. Also, if we took out the hawk from the ecosystem, what might we see then at our highest level of consumers? What's going to happen to those mice and those snakes? What effects are we going to see in the population? So, because of the rule of 10, most food chains have very few trophic levels. Really, it can max out at possibly 5 or 6 at the most. And we'll see these usually in aquatic ecosystems that have a lot of levels of very small consumers. So we'll see algae and their sort of phytoplankton, zooplankton, minnows, smaller fish, bigger fish, and then we can get up to our seals and whales and sharks and polar bears. And we really only see those in aquatic ecosystems. Typically in terrestrial ecosystems, 4, maybe 5 is as many as we're going to get to. Just because of the type of animals that we have there. So the amount of energy transferred from one level to the next ranges from 5 to 20%. But again, for the sake of bio, we're just going to go with the rule of 10%. The remaining energy is not passed off because it's not stored in those tissues. It's used up for thermal energy, so keeping our bodies warm, movement, producing waste, searching for food, running away from predators. All those different things use up our energy. So I hope you guys had a great day today in your lesson, and I'll catch up with you next time. Bye.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.